Alright, Railway Engineering, Copyrighted Materials, 2007, Oxford University Press. Chapter 14, Points of Crossing. Points of crossing are provided with the help of the transfer of railway vehicles from one track to another. The tracks make parallel, diverging, converging, each of the points of the crossing necessary because of the wheels of the vehicle. Railway vehicles provide for the inside of the plans, therefore require the special arrangement in order to navigate the way on the rail. The points of the switches that aid for the diverting of the vehicles crossing provided with the gaps of the rails and the rails as well as help the flange wheels to roll over them and complete the set of the points and crossings along with the lead rails is called the turnout. Important terms. The following terms are often used for the design and point of the crossings. The turnout is the arrangement of the point of the crossings which leave the means of the rolling stock may be diverted from one track to another, showing various constitutes of the turnout. The detail of the constitutes are given in Table 14.1. Direction of the turnout. The turnout is designated with the right or left-hand turnout depending on whether the divert to the traffic to the right or to the left. In Figure 14.1, the turnout is right-handed turnout because it diverts the traffic towards the right side. And Figure 14.1b shows the left-handed turnout. The direction of the point of the turnout is known as the facing direction. The vehicles are approaching the turnout point of the first face. The thin end of the switch, the direction of the trailing direction of the vehicle does negotiate. Switch of the trailing direction of the vehicle first negotiates the crossing final transversal one. The switch from the thick end of the thin to its thin end, therefore, with the standing of the toe of the switch. And if the one looks the direction of the crossing, is called the facing of the direction, and the opposite direction is called the trailing direction. Tongue rail, and the tapered removable rail, movable higher carbon magnesium steel, with a withstand the wear and a thicker end of it attached to the running rail. The tongue rail is called the switch rail. The stock rail is the running rail against the tongue of the rail operates. Alright, 14A constitutes the turnout. It shows the facing direction, the end of the stock rail, the stretch bar, the overall length, the overall outer straight rail, check rail, wing rail, outer curve rail, lead rail, inner straight lead rail, inner curve lead rail, wing flare, check rail, theoretical nose of the crossing, actual nose of the crossing, throw switch, toe of the switch, tongue of the rail. Figure 14.1b shows the left-handed direction. The facing direction, left-hand switch, right-hand, check of the rail, turnout, crossing, mainline, check rail. 14.1 parts of the turnout. Set out switch, a pair of stock rail with a pair of tongue rail with a pair of heel blocks, several slide chairs, the two of the more stretch bars, the gauge of the tie plate, crossing and nose crossing, a point of the rail which slices rail, the two winding rails and two check rails, the lead rail, the four sets for lead rail. Pointer or switch, the pair of the tongue and stock rail, the necessary for the connection fitting with the form of the switch. The crossing of the crossing device has been introduced at the junction of two rails crossing each other, permitting the wheel flange railway vehicle to process one or more track and another. 14.2 switches. A set point switches consist of the following main constitutes. 14.2 details of the switch. So you have the gauge, tie plate, pull rod, lever blocks, toe of the switch, tongue of the rail, stock rails, heel of the switch, stock rails, slide chair, tongue rail, and heel blocks. A pair of stock rails A, B, C, and D, A, B, and C, D, made of the medium magnesium steel. The pair of the tongue rails P and Q, R and S, are known as the switch rail, made with the medium magnesium steel withstand with the way the tongue of the rails are matched with a very thin section to obtain the snug fit with the stock rail. The taper end with the toe is called the toe, and the thicker end is called the heel. A pair of heel blocks will hold the tongue of the rails held with the standing clearance the distance of the stock rail. The number of the slide chairs that support the tongue rail enables the movement towards the wave of the stock rail. Two or more stretch bars being connecting both the tongue of the rails or closing the toe for the purpose of holding them fixed distance with each other. The guide, gauge, tie plate, and fixed gauges ensure the correct gauge of the points. Type of switches. Switches are two types, namely the stud switch and split switch. Stud type of the switch, no separate tongue of the rail, is provided with the sum of the portion of the track is moved from one side to the other. The stud switch is no more than in use in the Indian Railway. They have been replaced by split switches. These consist of a pair of stock rails with a pair of tongue rails. Split switches may again be two types, loose heel and type, and the fixed heel type. They are discussed below. Loose heel type. This type of the split switch, the switch tongue rail finishes the heel of the switch and enables the movement of the three end of the tongue rail. The fish plates holding the tongue rail may be straight and slightly bent. The tongue rail fish fastened. The stock rail will help the fishing fit block and four bolts. All fish bolts and lead rail with the tightened while those of the tongue rail are kept in loose and snuggled. All allow the free movement of the tongue and discontinuity of the track of the heel. Weakness of the structure. Use of the switch is not preferred. The fixed heel type, the type of the split switch, the tongue rail does not end with the heel of the switch but extends further. The rigid connected with the movement of the toe of the switch is made possible, accountable, flexible down with the tongue rail. Toe of the switch. The toe of the switch may be either the following types: undercut switch of the foot stock with the joint and stock rail is planted to accommodate the tongue rail. Figure 14.3. 14.3 is the undercut, shows the stock rail, the 6 millimeters from the switch rail, overriding switch. In this case, the stock rail occupies the full section of the tongue rail and plane in 6 millimeters or a quarter inch thick edge that overrides the foot of the stock rail. The switch rail is a quarter inch higher than the stock rail, the heel to the point of the towards the toe, where the planing starts. This is done to eliminate the possibility of splitting the cup by any of the false flanges moving in the trailing the direction of the design. Consider the economical superior design due to the reason given below. Since the stock rail is uncut, it's much stronger. The manufacturer work is confined under the tongue rail, which is very economical. Although the tongue rail is that thin edge of only 6 millimeters or quarter inches, supportive of the stock rail with the entire weakened portion of the length. As such, the combined strength of the rails between the sleeper and the greater than the tongue of the rail alone with the under switch. Overriding switches have been standardized in Indian rails. Figure 14.4 shows the overriding the stock rail with the tongue rail split from spring washer and wheel. 14.2 important terms pertaining to switches. The following terms are commonly discussed for the design of switches. Switch angle, the angle with which the gauge of the face of the stock rail, the tongue is the theoretical toe with the switch with closed position. Its function with the heel divergency of the heel of the tongue of the rail. Flange way distance. The distance between the adjoining face of the running wheel, check of the railway wing, rail nose of the crossing, and meant with providing with a free pass of the wheel. Flanges table 14.2 give the minimum and maximum flange way clearance of the broad gauge, minimum gauge, broad gauge, maximum value 48, minimum value 44, meter gauge 44, maximum value 41. Heel divergency. The distance between the gauge face of the stock rail with the tongue of the rail with the heel of the switch is made up of the flange clearance for the width of the tongue of the rail head at least to the wheels. Throw over the switch. The distance throw of the tongue rail move their laterally toe of the switch allow the movement of the trains, limiting the value of the 95 to 115 millimeters broad gauge routes, 89 to 100 millimeters for meter gauge routes. 14.3 Design of the tongue. Tongue rails may be either straight or curved. Straight tongue rails have the advantage of the easily manufactured, can be used right-handed as well as left-handed turnouts. However, the joint of the train, the negotiation with a straight tongue rails turn out because of the abrupt change within the alignment of the straight tongue and the rails are normally used in 1 in 8.5 or 1 in 12 turnouts in the United Indian Railways. Curved tongues rails shall be according with the curvature of the turn through the toe of the heel of the switch. Curved tongue rails allow the smoothing of the turn of the train, but can also be used with a specific curvature for which they are designed. Curvature switches that are normally from 1 in 16 to 1 in 20 Indian Railways standards turn out the Indian Railways. Recently, Indian Railways has also started laying 1 in 8.5 and 1 in 12 turnouts of the curved switches in important lines. 14.3.1 Length of the tongue rail. Length of the tongue rail from the heel to the toe varies with the gauge of the angle with the switch. The longer length of the tug and the smaller entry of the switch becomes the smaller angle with the switch rail with the can make the fixed heel with the divergency long length of the tongue rail. However, the occupies too much layout space station where the number of the turnouts have to be limited space. Length of the tongue rail should be more than rigid wheelbase of the four-wheel wagon, precluding the possibility of derailment in case the points move with the position which the train is running of the switch. The figure 14.3 gives the standard lengths of the switches and tongue rails of the broad gauge and meter gauge. Alright, broad gauge 1.85 straight millimeters 4,725, 1 in 12 straight millimeters 6,400, 1 in 12 curved 7,730 millimeters, 1 in 16 curved 9,750, 1 in 20 curved 11,000. 150. The meter gauge 4,000, 1 in 8, 4,000 and 1 in 16, 5,000, 485, 1 in 12, 1 in 12 curved, 6,700, 1 in 16 curved, 7,420. The asterisks dimensions hold good for the narrow gauge also. At crossing of the front of the device, introduce the point of the two-gauge cross with each of the plane permit the flange railway vehicle to put with one track to another to achieve the objective of the gap provided with the throw of the nose of the crossing over which the plane guides with the jump in order to ensure the flange wheel negotiates the gap properly does not strike the nose of the other wheel of the guide with the help of the check of the rail. The crossing consists of the following components shown in figure 14.6. Two rails point up the rail splice rail, which are machined from the nose of the two-point rails end of the nose, where the splice joints in the left hand behind the nose. Theoretically, the points of the rail should end of the point and be as made, but there is possible the knife edge of the point rail would break off under the movement of the track of the point, thereby is the fine end slightly cut over the blunt nose with a thickness of 6 millimeters or quarter inch. The tooth of the blunt nose is called the actual nose of the crossing, or ANC. The theoretical point with a gauge facing on both sides of the inspect called the theoretical nose of the crossing, or TNC. velocity with the V rail is placed in the depth of the 6 millimeters, a quarter inch, for the nose runs at 89 millimeters to stop the wheel running facing direction from hitting the nose. Details of the crossing: face of the direction, toe of the crossing, left hand, right hand wing rail, throat gap, the theoretical nose of the crossing, and actual nose of the crossing, flange way, flare, slat, splice rail, point rail, and crossing angle, heel of the crossing, and overall length of rail direction. 416 point of the rail and splice rail. Splice rail, heel, and point rail, flare, right hand wing, left hand ring, actual nose of the crossing, throat, theoretical nose of the crossing, elbow wing of the throat. Two wing rails consist of the right hand and left hand wing rail with the convergence of the throat diverging either side of the nose. Wing rails have flared end for the facilitate entry of the existing flange way in the gap. The pair check with the rail gap with the wheel flange provide with the path of them, thereby preventing them from moving the sideways, which could otherwise be a result of the wheel hitting the nose of the crossing and a move of the face of the direction. 1441. Type of the crossing. Crossings made by the following types. An acute angle of the crossing. V crossing is an intersection of the two gauges of the forms acute angle. The example, the right rail crossings from the left rail makes an actual crossing the unlikely rail crossing from the actual acute crossing. A and C, figure 15.9. Obtuse diamond crossing in which the two gauges face meet in an obstacle angle with the right and left crosses with the similar rail makes the obtuse angle B and D with the figure 15.9. Square crossing. The two tracks crossing at the right angle. Such crossings are rarely used in a practice. Practice 14.7. 14.7 serves the square crossing. For manufacturing process, the crossing can also be classified as follows. The built-up crossing, built-in crossing, two-wing rail with the V section consisting of a splice of the point rails assembled together with the beams of both distance blocks of the form of the crossing. Type of the crossing commonly used for the Indian Railway shows crossing has advantage and initial cost with the low with the repair for the carry with the simply welding replacing each of the consistent separately with the crossing becomes unserviceable where with the 10 millimeters of built or 3/8 inch of the crossing. However, the lack of the rigidity the both require the frequent check can sometimes break under the fast and heavy traffic. Your cast steel crossing, one of the piece with no bolts, therefore requiring very little maintenance comparatively more rigid sensitive. That consists of one complete mass. The initial cross with such crossing, however, is quite higher in repair and maintenance posed for the number of problems. Recently, the cast magnesium steel crossings, which have no longer life, have also been adopted. The combining rail and cast crossing, the combination built up in the cast steel crossing consists of the cast steel nose furnished with the ordinary rails to the two legs of the crossing. This allows the welding to worn out the wing and rail. The nose is still liable for the fracture suddenly. Alright, 14.4.2, the CMS, crossing. Due to the increase of the traffic that use the heavy extra loads to ordinary built without crossing manufactured for the medium magnesium rail subject to the heavy wear and tear of especially the fast line suburban section, but the electrical traction past experience has shown the life of such crossing varies from 6 months to 2 years depending on the location and surface condition. The CMS crossings possess the high strength over the measurement more resistant with wear. Consequently, they have a longer life. The following main advantages of the CMS crossings: less wear and tear, longer life of the average of the CMS crossing, about 4 times more than the ordinary built up of the crossing. CMS crossing free bolts of the bolts as well as other component normally would tend to lose as a result of the manual traffic movement of the traffic. These days, the CM crossing preferred with the Indian Rail through the initial crossing of the costing of the hive with the maintenance cost is relatively less, lasts longer. However, the special care may be taken in light of the maintenance. However, keeping in this point view, the CMS crossing has been standardized with the Indian Rails on account of the limited availability. CMS crossing is in the country, thereby if you have been restricted to time being grown, time and being to the group of the routes have the lines of other routes of the traffic density of over 20 gross million tons should have reserved for you for the heavy work from all the groups in the busy yard. Alright, 14.4.33, crossing and movable crossing. Screen crossing, one wing rail, movable head against the V of the crossing, strong heel, the helical spring with all the other wing rails fixed in 14.8. Vehicle passing on the main track, movable wing rail is snug with crossing of the vehicle does not need to negotiate any crossing escape. The vehicle has to pass over the turnout. The movable works and force for the wheel flange of the vehicle to negotiate the gaps in normal turnout. The type of the crossing is useful. The high-speed traffic, the main traffic, the slow speed, and the traffic of the turnout. Alright, 14.8, the spring movable of the crossing. The movable wing, hold down box, fixed wings, helical spring, gauge, stop, turnout match, track, machine track, and gauge. 14.4.4, raise track and the raised obtuse crossing. In order to provide gauge pathway with route position 1 and 8.5 broad gauge obtuse diamond crossing, check rails raised by the well, link of 25 millimeters thick MS plate with arrangement considered with the manufacturer of the broad gauge as well as meter gauge routes. Alright, 14.4.5. Position of sleeper at the deployment of the crossing. Sleepers are normally perpendicular with the track at the point of the crossing situation area, with the sleeper that have to enter the main line as well for the turnout portion of the crack. The purpose of longer sleepers are used with the sum of the length of the track is shown in figure 14.9. Sleeper from the point of the crossing should points and curved track, straight track. 14.5. Number and angle of the crossing. The crossing designated with the angle of the gauge of the face of the bank. Either the more commonly number of the crossing replaced by the m there as a method of the number of the crossing. The value n also depends upon the method. Also, methods illustrated in figure 14.10. Your center line method of Britain in the U.S. In this method, n is measured along with the center line of the crossing. Or cotangent of A is over 2 with it equal to n divided by 1, 2, 9, n divided by is equal to 1/2 over the cotangent A2. Center line A of the n in 1 meter, A and 1 meter, right angle. Center line method, and isosceles triangle method, A and 1 meter. Right angle method, the method of Indian Railways is method if the n is measured at the base for the right angle, this is called the Coles method, or cotangent A is equal to n over 1, or n is equal to cotangent A. The isosceles triangle is a method, n takes only with the equal side isosceles triangle. The A is sin is A over 2 with it equal to 1/2 over n, or n1 divided by 2n. Cosecant A over 2 equal to 2n, n equal to 1/2 of the cosecant A over 2. The right angle measure for the Indian Railways, which for the n is the cotangent angle of the form, the two-gauge face for which give the smallest angle with the same value, and determine the number of the crossings n on the site of the point of which the offset with the gauge of the turnout track is 1 meter with marked. The distance for the point is meters from the theoretical node of the crossing gives n. Or reconditioning of worn-out crossings. General node of the crossing wing rails undergo the maximum amount of the wearing of the turnout, the little wearing of the crossing of the 10 millimeters, after which the required to replace the worn-out crossing. Generally recondition the stage with wear of the only 6 millimeters or quarter inch. The case for the tongue rail is limited to vertical 52 kilograms 90 R rails of the 6 millimeters 1/4 inch. That later wear of the 8 millimeters, similar limited vertical wear of 60 R of the 75 R with the 60 millimeter 6 millimeter of the little wear of the 5 millimeter. Normally gas welding adopted the reconditioning crossings as the site itself. The sequence operation is followed. The advanced part of the preliminary work with complete with the detailed attention for the pave. The turnout include throughout the packing, replacement of the worn out fittings, the tightening of the fitting, squaring, and the spacing of the sleeper, etc. Both vertical and side wear mentioned with the help of the 1.8 meters of the straight edge there, as well whereas welding is to be done with the clean and burns that are to remove the chalk. 3. The surfaces to be welded are clean and burned but are removed from by using a chisel. Welding is done with the help of the oxyacetylene flame, with using suitable welding rod with the preheating of the surface about 4 or 5 minutes. The section built up with the thickness required of the deposit metal with its hammer to make the uniform level surface. Prepared a surface is checked with the help of the straight edge. The caution order of the 10 out of the work of the progress. No speed restriction necessary. One welding party consists of the one permanent way mystery with the craftsman's 2 welders, 6 calluses, laborers work, including lookout with the man with a good weld, and 1 cross the 2 pairs of switches every working day. The consumable items require reconditioning work and listed in table 14.4. Alright, consumable required reconditioning crosses. 1 cross at 5.7 meters oxygen meters cubed, 6.5 oxyacetylene meters cubed, and welding rods 1.6 kilograms. 1 pair of switches 2.3 meters cubed, acetylene 3.0 meters cubed, welding rods 0.75 kilograms. Alright, 14.7. The turnout. Simplest arrangement of the form of the cross could be found with the turnout taking off the straight track with the 2 standard methods prevalent with the design of the turnout. There is also the A. Cole methods and B. the IRS method. The method described in detail with the Indian Railway surface method. The method described in detail the following section. The important terms that describe and design the turnouts are defined as follows. The curved lead, the distance of the tangent point of the theoretical node crossing, the measure for the long length of the main track. Switch lead, the distance of the tangent point with the heel of the switch, the measure for the long length of the main track. Lead over the crossing distance measured along with the length of the main track as follows. Lead crossing equals the curved lead minus the switch lead. Gauge, the gauge of the track, the height, heel divergency, the distance between the main line and turnout of the side of the heel. Angle of the crossing, angle between the main line and the tangent, the turnout line. Radius of the turnout. The radius of the turnout may be clarified, but the radius of the turnout equal the radius of the center line of the turnout, R1 plus the half of the gauge. The R equals R1 plus 0.5 gauge. The radius of the curve is quite larger for a particular purpose. R may be taken as the equal R1. Special fitting of the turnout. Some of the special fittings required for the use of the turnouts enumerated below. The distance blocks. Special type of the distance blocks when fishing fit with the surfaces that are provided with the nose of the crossing to prevent the vertical movement between the wing of the rail and the nose of the crossing. Flat bearing plates of the turnout do not have any cant. The flat bearing plates are provided until under the sleepers. Cylindrical washers. They are a special type of the washers consist of two pieces of cylindrical point with a contact between them. The point of the two surfaces lie in an angle to each other. These washers are used for connecting the two surfaces that are not parallel to one another. Normally, tap washers are necessary for the connecting soft surfaces. Cylindrical washers can be adjusted uneven bearings with the head nut of the bolt. These are used with all the bolts in the heel with the distance of the blockhead blocks behind the heel on the left hand of the side of the track. Slide chairs. They are provided under the tug rails to allow the move laterally. They are different from the ordinary switches over the riding switches. Grade off chairs. Special chairs are provided behind the heel of the switches to give it a suitable ramp at the tongue rail which raised at 6 millimeters at the heel. Gauge type plates. They are provided out of the sleeper directly under the toe of the switches to undergo the nose of the crossing to ensure proper gauge for these locations. Stretch bars. They are provided to maintain two tongue rails at equal distance. Cole's method. The method of designing the turnout taking off the straight track with the curvature being the point of the straight main track ahead of the toe of the switch, the theoretical toe of the switch, and the theoretical nose of the crossing. The heel of the switch is located at the point where the offset of the curve is equal to the heel divergency. Theoretically, there would be no thick kinks in this layout laid of the tongue with the being curved as well as the wing rail up at the theoretical nose of the crossing. Since the tongue rails, wing rails are not curved generally, they are the following three kinks in the layout. Alright, figure 14 shows the turnout of the straight track, R, A, T, switch lead, tangent points, M, L, C, divergency, angle 1, A, angle 2 and 2, the angle A, gauge E and R, radius of the curve, number of the crossing, curve lead, tangent points, angle crossing, switch lead, divergency. First kink forms the actual toe of the switch. The second kink forms the heel of the switch. Z. The third kink forms the first distance between block with the crossing notation. The figure 1411 as the following: curve lead CL is equal to A equals TE and foot, and the switch lead the SL and T equals TL. Lead crossing L equals LE. Gauge track of the G equals AT equals EE. The angle crossing A equals angle C, EA, and angle ECE. Heel divergency D equals LM. Number of the crossing N equals cotangent A. The radius out of rail turn curvature R is equal to OE equal to OT. O is the center of the turnout curve. Calculations curve literature at the angle at triangle AT. The AT is equal to G. A and angle AET is equal to A over 2. Tangent A over 2 is equal to AT over EAE equal to G. The gauge over the curved lead or curved lead is equal to gauge over the tangent A over 2. The curved lead, also the curved lead, E foot C plus C, E plus CT, EC plus CE is also equal to CT is equal to CE. The gauge of the cotangent age and the cotangent of the cosecant age and the gauge number that equals the gauge of the square root of 1 plus the number and squared as is, and cotangent is A is equal to number 2GN is approximately 2 gauge number cotangent N is approximately 2GN approximately. Switch lead. The TL length of the tangent is offset by the LMD with the heel of the divergency from the property of the triangle. The SL times SL is equal to D times 2R minus D, or switch lead is equal to the square root of 2RD minus D squared. Lead of the crossing L is equal to the curved lead minus the switch lead over the equal to cotangent gauge of the cotangent A divided by 2 is minus the square root of 2RD minus D squared. The radius of the curve is in the triangle AOE is OEE is equal to OT over the equal to R. OA is equal to R and minus G, and OE squared over the equal to OA squared plus AE squared. OE is equal to R minus G squared plus curvature curve lead squared. Alright, summarizing formula derived. Curve lead CL is equal to gauge cotangent A and E over the 2G, and approximately switch lead is SL equal to the square root of 2RD minus D squared. Leading across L is equal to the gauge of the cotangent A over 2 minus the square root of TRD, the square root of 2RD minus D squared. or 2gn minus 2rd square root of 2rdg squared. Radius of the curve r is equal to 1.5 gauge plus the 2 gauge and n number squared. Hill divergency d is equal to the SL squared over the 2 times the r plus g and a half g half. Alright, calculate the lead radius of 1 and 8.5 broad gauge turnout with a 90R rail with using the Cole method. G is equal to 1.66 millimeters. D is equal to 120 millimeters. A is equal to 6 degrees, 42 feet, and 35 inches. And N is numbered to 8.5. You have the curved lead of 28.6. The radius of the turnout curve of 245 meters. Switch lead 7.6 meters. And the lead is equal to 20.9 meters. IRS method. In this layout, figure 14.12, the curve begins with the heel of the switch, aim for the toe of the crossing, which is the center of the first down, distant black with the crossing straight, and no kink is experienced at the point. Only the kinks occur with the toe of the switch. The standard layout of the Indian rails calculations involve the method somewhat complicated. Hence, this method is only used only when precision is required. Turn out of the straight curved IRS method. Lead crossing, triangle BMH, BM is equal to MH as both tangent angled MHB is equal to BMH, angle minus B squared, BC is equal to AD minus AB plus CD equal to G minus D plus H, sin A, therefore crossing the L is equal to G minus D, the A minus H is sin A, cotangent A minus B squared over the cotangent A minus B divided by 2 plus the H cosine AA. Radius curve of the triangle OBH. BOH is the angle A minus B, angle minus B. BH is equal to 2R, the sin of A, angle A minus B, and divided by 2. The BHC, the BH is equal to BC over the over sin A plus B divided by 2 equal to G minus D minus 8 sin A and sin A plus B minus 2. Equating equations. Radius G minus D minus H sin A divided by the 2 sin A plus B divided by 2 times 2 sin plus H plus minus B the 2, or G minus D by H sin A over the cosine B with the cosine A. Calculate the lead radius of the 1.85 broad gauge turnout straight with the switches. The IRS method gauge is 1,676. The D is 136 millimeters. Height is 864 millimeters. Angle is 6 degrees 42 and 35 feet. B is 1 degree 34 and 27 degrees heat. Approximately 20,729.89 millimeters. Approximately 20,730 millimeters radius. 222,360 millimeters. A turnout is to be laid with a straight with the broad gauge within 1 and 12 of the crossing. Determine the lead of the radius. Determine out with the help of the following data. Heel divergencies D 130 millimeters. Crossing angle 4 degrees 45 feet 49 inches. Switching angle 1 degree 8 foot and straight length between theoretical node of the crossing and the tangent point crossing H of 1.4 and 1.8 millimeters. You have the radius of 437.38 meters and cross leading of 29.084 millimeters. Standard turnout and permissible speeds. On Indian Rail is normal to 1.8 turnouts are used for the good trains, while in 1 and 12, the 1 and 16 turnouts are used for passenger trains. Recently, 1 and 20 and 1 and 24 turnouts have been designed with a research design state under organization to be used for permanent higher speed for faster trains. Turnouts by the maximum speed rate, but these turnouts are given in table 14.5. Broad gauge 1.85, 1 degree 34 and 27 inch of the 10 straight switches, the 15 curved switch, which is 5260 kilograms. The PSH swoop of the broad gauge 1.85 symmetrical split 0 degrees 27 feet 35 feet. Broad gauge 1 and 16 foot, 1 degree 8 foot and 0 degree 24 27 foot 50 or 60. Meter gauge 1.85, 1 degree 35 foot 30, 0 degrees 29 foot 14 inches, 10 of the straight as well for the curved switch. Meter gauge 1 and 12, 1 degree 0 9 foot 3 eighths, and the eighths of an inch or 0 24 foot 27 inch, 15 straight. 15 for straight fitted for all the parties from curved switches. Meter gauge 116 0 24 foot 27 inches. Permissible speed 30 miles an hour. 14.8. Turnout with a curved switch. The following formula used for the calculation turnout with the curved switches. Radius is equal. That's a large question. Where R is radius for the outer lead with the gauge, the H for the gauge, H for the lead with the straight leg with the crossing of the theoretical node for the closure, and of the TP with the lead curve of the T. Thickness of the switch for the toe, then L is I is the distance for the toe of the switch for the point from the tangent for the drum with the extent of the large lead of the curve parallel to the main lane gauge face. For the V is the distance between the main line gauge face and the tangent drum with the lead curve of the distance of one from the toe of the V is Y is for the vertical ordinate along the y-axis, A is the crossing angle, and B is the switching angle. Alright, 14.9 is to lay out the turnout and field with the value of the offset with the gauge face for the straight track with the gauge for the turnout adapted from table 14.6. 14.10. Trends for the turnout design in Indian Railways. The main factor of the responsible for the low speed over the turnouts of the Indian Railways are as follows. Sudden change of the direction running engine for the upon entry of the switch of the track. Absent transition between the curved lead with the straight crossing. Non-transitional entry with the curved length lead to the straight crossing. Absence of the super elevation over the turnout curve. The gap of the curve phase for the corroding table of the crossing variation for the cross level of the cost of the switch rail. In order to achieve the higher speed with the turnouts necessary for all the limitations of the design turnout overcome as far as possible. European countries' design the turnouts have been greatly improved with the speed of the more than 100 kilometers an hour permitted with the turnout curve. The main feature of the design of these turnouts are following: long curved switching for the provided with the void, the abrupt change of the direction of the vehicle, the entry of the switch crossing the curve of the same with the radius lead with the curve, alternately transition curve of the provided with the toe of the switch from the node to the crossing to provide a smooth passage for the train of the turnout curve. See, the higher cant deficiency permitted the disadvantage of the providing super elevation of the turnout curve to duly compensated and keeping the trend of the railways world to permit higher speed with the turnout. Indian Railways consider standardization of high-speed turnout following conditions of the track. For the good yard for the maximum permissible 25 kilometers an hour. For the passenger yard for maximum permissible speed 50 kilometers an hour. Parentheses of big yards and bypass lines are maximum permissible speed 75 kilometers an hour. Junction of the single line and the double line section of the maximum speed of 100 kilometers an hour. The design of 1 in 12 passenger turnouts of the passenger yard, thick web of the tongue, and the CMS crossing has also been finalized and enabling the maximum speed of 50 kilometers an hour. Similar with the new design 1 in 24 turnout, big broad gauge will curve the switch, the thick web tongue rails, and spread potentially 160 kilometers an hour. It's finalized by the Indian Railways. Alright, 14.11. Inspection maintenance points for the crossing. Points for the crossing should be inspected for the detailed quality with the train ride greatly dependent for the maintenance. Following importance should be checked. The condition for the tongue of the rails and stock rails, they should be done where over the top of the well of the gauge face side with the tongue rail boardly worn out rails should be replaced. It should be ensured that the turnout of the stock rail is provided with the request bend of the head with the whole switch, otherwise the line with the spot is found link kinking. Condition of fitting of the tongue of the stock rail. The fitting should be tight with the cylindrical washers must be played for the correct location. Slide chairs may be clean, free of grease from the graphite with a smooth operation. But the points fish place should be provided with the correct amount of the bend and loose. The heel joint, the gauge tie place should be added. And the provision of the same have not been made. The gauge cross level to switch, but some of the gauge cross levels should be in the check for the correction of the following location: stock joint, 150 millimeters, 6 inches beyond the toe of the switch, and from the mid switch with the straight track for the turnout side, for the heel of the switch with the straight track for the turnout side. Clearance of between the stock tongue of the rails or heel of the switch with the correct divergency. The provided with the heel of the switch should be as follows: the broad gauge 133 millimeters for 116 and 112, 1 in .8 and 5, 120 millimeters. Meter gauge 117 millimeters, 116 and 112, 120 millimeters, 1 and 8.5. Throw of the switch. The throw of the switch should also be as follows: broad gauge 150 millimeters, recommended 95 millimeters minimum. Meter gauge 100 millimeters, recommended 89 millimeters minimum. Condition of the crossing of the tongue and the coordination of the crossing of the fitting of this should be termed checked with the maximum vertical wear permitted with the point of the wing rail. The 10 millimeters should be reconditioned. The wear of 6 millimeters burn bars should be removed. The fitting should be tightened. The maximum vertical wear permitted with the tongue rail 6 millimeters wear is permitted with the lateral wear of the 8 millimeters and 90 hour with the 52 kilogram rail with the 5 millimeter 60 hour and 75 hour rails. Tongue rails should be replaced and reconditioned before the value of the reach of the railway board has recently decided the maximum vertical wear of the wing rails of the nose of the crossing should be less than limited to 4 millimeters of Rajan and Stabati routes of the 6 millimeter all routes. The wear of the limits of CMS crossings, however, the 5.5 millimeter Rajan and Shabdati routes of the 7.5 millimeters are other routes. Gauge and cross level of the crossing. Assembly of the gauge of the cross level should be checked with the following location should be always correct with 1 1 meter ahead of the nose of the straight track with the turnout, 150 millimeters, 6 inches behind the A and C, or actual nose curve, straight track of the turnout, 3 and behind the actual nose of the straight tracks and turnout. Check rail. The condition of the check rail should be concerned with the check rail clearance should be below as broad gauge with the 48 millimeters minimum, 44 millimeters meter gauge, 40 millimeters, 41 millimeters. The curvature of the curvature should be checked. Either the offset method, the reverse line method, the curvature should be correct on the uniform. The cross level to the straight track with the turnouts, cross level on the straight track. The turnouts should be checked so that they see that they are correctly in all places. Sleeper, the condition of the sleeper, the fittings should be checked. Unserviceable sleepers should be replaced with the squaring of the spacing of the sleepers should be proper, then they should be well packed. Bells ranged enough quantity with the valves should be available so that it provided the adequate cushion. The drainer should be drainage should be proper. Any of the other defects, if there is any other defects in layout, there should be checked with the corrected. Special attention is required to ensure the sleepers are well packed and all fittings are tight on the gauge for the cross level to properly maintain the wear of the tongue of the rail, as well as the crossing of the permanent limits. Also should be ensured the proper distance blocks of the provided with the correct location of the schedule of the inspection of the Indian rails given in table 14.7. Turnout. The turnout summary. The turnout integral of the railway track combination of the lead rail with the point of the crossing provided with the 2 tracks connected with the branch line. Introduced the various features of the design of the turnouts have been discussed in the chapter. The design examples that have been included. The possible various types of track junctions, different combination points of crossing. This is described. They are described in chapter 15. Chapter 15. Track junctions, simple track layouts.